This is one of the most puzzling questions in modern space science. We still can't say for certain what truly lies inside a black hole. And yet, the answer might be surprisingly simple. Some scientists are deeply convinced that what's inside is us. According to this view, not only is it possible, it's even highly probable that our universe was born within the core of one of these massive cosmic beasts. Incredibly, this idea has recently gained support from a new observation made by the James Webb Space Telescope. But how could that possibly be? After all, black holes are known for obliterating anything that comes too close. Or are they? Well, not exactly. Keep reading, because we're diving into the bold possibility that you might actually be inside a black hole right now. The universe is a masterful creator. It has given rise to regions so intense, they throw everything nearby into utter chaos. These are objects that devour anything that ventures too near, from which nothing can escape, and that shatter the rules of the cosmos as we know them. We call them black holes, but black holes don't all fit into the same category. At the smallest scale, there are stellar black holes, formed by the collapse of massive stars. In more detail, when a star burns through its nuclear fuel, it sheds its outer layers in a dramatic supernova explosion. What remains? Its core collapses under immense gravitational force, forming a stellar black hole. These typically weigh between 3 and 10 times the mass of our Sun, but things get even more astonishing with supermassive black holes. As their name suggests, these are far larger and more powerful than their stellar cousins. With masses millions or even billions of times greater than that of the Sun, it is now widely accepted that nearly every galaxy, including our own Milky Way, harbors a supermassive black hole at its center. Ours, known as Sagittarius asterisk, weighs in at approximately 4.3 million solar masses. The exact origin of these galactic giants remains uncertain. Scientists speculate that they may have formed either through the gradual merging of smaller black holes or from the direct collapse of vast gas clouds early in cosmic history. What's certain, however, is that these entities shape everything around them. Supermassive black holes play a fundamental role in the formation of galaxies and are responsible for the incredible energy of quasars, some of the brightest phenomena in the universe. Their event horizons can stretch millions of kilometers wide, large enough to span entire planetary orbits. Yet what defines a black hole more than anything is its ability to consume anything that crosses its boundary, the event horizon. They are cosmic engines of destruction. This destructive power comes from their extreme compactness. A black hole with the same mass as Earth would be compressed into a sphere just 9 millimeters wide. This staggering density creates a gravitational pull so intense that not even light can escape. For this reason, black holes themselves are invisible. What we can see, however, are the violent forces acting around them. In 2019, astronomers achieved a historic milestone. They captured the first image of a black hole using the Event Horizon Telescope. This black hole lies at the center of the galaxy Messier 87, about 55 million light-years away, and has a mass of 6.5 billion suns. A few years later, our own Milky Way's black hole was also imaged. But here's the question: how can such enormous black holes exist at the centers of galaxies without tearing them apart completely? The truth is, while they can consume entire planets, stars, and colossal gas clouds, objects must pass extremely close within the event horizon to be swallowed. Outside this boundary, black holes act like any massive celestial body, allowing other objects to orbit them in stability. But what happens if something does fall into one? What lies within the belly of these gravity monsters? We have a reasonably good idea of what happens as one nears a black hole's event horizon, that infamous point of no return, although the process by which supermassive black holes form is still being unraveled. We do have theoretical models for what could lie inside them. In short, the interior of a black hole is where physics as we know it ceases to apply. Many calculations suggest that space and time become warped, chaotic, or altered in unknown ways. At the heart of a black hole is believed to be a singularity, a point where density, gravity, and spacetime curvature become infinite. This presents a serious problem because at a singularity, our current understanding of physics breaks down entirely. Einstein's theory of general relativity, so far a cornerstone of modern physics, can't offer meaningful predictions in this environment. Because of this, some scientists challenge the idea of an infinitely dense core. Still, if a person, say, an astronaut, were to fall in, they would undergo a dramatic process known officially as spaghettification. This term refers to the way intense tidal forces would stretch and distort the body so drastically that it would resemble a long strand of poster. This applies to all matter, which makes sending a probe into a black hole currently impossible. With no way to observe what happens inside directly, scientists turn to theoretical models. One fascinating possibility is that black holes and their opposites, white holes, could form a wormhole. In theory, matter falling into a black hole might reappear elsewhere through a white hole, possibly in another region of space, or even another universe entirely. White holes are hypothetical objects that, unlike black holes, emit matter and cannot be entered from the outside. However, despite being valid solutions in general relativity's equations, white holes remain purely theoretical and have never been observed. But there's another radical theory gaining traction proposed by physicists such as Nikodem Pavlovsky. He suggests that we might not just be observing black holes from the outside. We might be living inside one. According to this theory, a black hole could serve as a kind of cosmic seed. When the matter it consumes reaches a critical point and can't be compressed any further, the seed bursts, initiating the birth of a new universe. In this view, a black hole could act as a transitional portal between two universes. If one could survive the journey through, they might find themselves in a completely different cosmos. While this idea may sound far-fetched, it recently gained support from new data collected by the James Webb Space Telescope. A research team led by Lior Shamir at Kansas State University analyzed more than 260 early galaxies in a region known as the Jades Field. Webb's observations revealed a strange pattern. About 2/3 of these galaxies rotate clockwise, while only 1/3 rotate counterclockwise. This finding is unexpected. In a truly random universe, we would expect galaxy spin directions to be evenly distributed, but if our universe formed inside a spinning black hole, this imbalance makes sense. According to Pavlovsky's hypothesis, the spin of the parent black hole could influence the rotational preference of galaxies in the new universe it creates. This idea also aligns with a framework known as Schwarzschild cosmology, which proposes that our entire universe exists within a black hole in a larger mother universe. In this model, every black hole could represent a gateway to a new, branching baby universe shaped, in part, by the properties of its origin.